Alright, in this video we're going to do some examples of using the special factoring formulas. Now, I did another video where I talked about the actual formulas, the special factoring formulas, where I kind of explained what they were and how they work. So if you didn't watch that video yet, you might want to look at that one before you look at this one where I actually do the examples. Alright, so the first one we have here, 9x squared minus 4, and we have to factor that. So this one is using what we call the difference of squares formula, and one of the clues of when to use the difference of squares formula is there's only going to be two terms there, right? If you have a trinomial with 3 terms or something with 4 terms, those are never going to be a difference of squares, right? A difference of squares always has 2 terms. There's always subtraction there, right? Because it has to be a difference, and difference means subtraction. And then the 2 terms that you have are perfect squares, right? So you can think of this 9x squared minus 4 as, well, the square root of 9 is 3, the square root of x squared is x. So that's 3x squared minus, and then the square root of 4 is 2 squared. Right? So it's 3x, that being squared gives us 9x squared, and then 2 squared gives us the 4, right? And that's a difference of squares, right? Because it's 2 perfect squares being subtracted from each other, right? So, you know, like I said in that other video where I explained these formulas, when you're dealing with a difference of squares, it comes up kind of a lot in algebra and precalculus and calculus. So it's really important to be able to identify it and then also to be able to factor it. And you know, if you know what the formula is for factoring a difference of squares, it's not real hard to do. Right? There's not a whole lot of work to do for it. Most of the work is mentally just identifying it and then remembering the formula. Right? So again, to identify 2 terms with a subtraction, both of those terms are perfect squares. So to factor this 9x squared minus 4, I take, well, it's going to factor into 2 parentheses, right? 2 binomials, 2 parentheses that have 2 terms in them. All right, so I take the square root of the 9x squared, which was that 3x that we had over there. So my first term in each parenthesis is going to be a 3x. The square root of the 4 is 2, right? So that's my second term in each parenthesis is a 2. And then one of my parentheses I put a plus in the middle, the other one I put a minus. All right, so 3x plus 2, 3x minus 2. That's our factoring of 9x squared minus 4. All right, so that's how we can factor a difference of squares. Again, it's not real hard to do. It's just identifying it and then remembering. All right, so the square root of this is 3x and 3x. This one is 2 and 2, 1 plus, 1 minus. And it doesn't matter, like you can put the plus here or the minus here. As long as one is a plus and one is a minus, it doesn't matter which one goes where. Right? And just like any other type of factoring, if you want to check it out, multiply it back together. But if I FOIL these binomials here, when I do 3x times 3x, that's 9x squared. When I do the outer terms, 3x times minus 2, that's going to be a minus 6x. When I do the 2 times the positive 3x here, that's going to be a plus 6x. And the minus 6x and the plus 6x are going to cancel out. Right? That's why one of these gets a plus and one of these gets a minus, so that when I do those inner and outer terms, they're always going to cancel each other out. And then the positive 2 times the minus 2 gives me that minus 4. Right, that's why the difference of squares formula is what it is, right? Because the first terms, when those are the same thing, right, that's squaring the 3x to give me 9x squared. When the last terms are the same, right, the 2's, when I square the 2, it gives me the 4. The 1 plus and 1 minus makes this a minus 4. And the plus and minus also makes it so that when I do the inner and outer terms, they cancel out. Right, so that's how we factor a difference of squares. Again, really important to know how to do that because it comes up a lot. All right, the next one we have here, x to the third plus 64. All right, so this one is not a difference of squares, right? For one thing, x to the third is not a perfect square. Also, there's a plus here instead of a minus, right? So this one is actually going to be what we call a sum of cubes, right? X to the third power, obviously that's a cube, right? It's a third power. And 64 is also a cube, right? 64 is 4 raised to the third power. All right, so what we have here is an x raised to the third power plus a 4 raised to a third power. And so that's a sum of cubes, right? It's a sum of cubes because it's a plus. If there was a minus here, it would be a difference of cubes, which we would also factor in a very similar way. All right, so to factor a sum of cubes, there is a formula for it. I actually don't have the formula memorized, but I understand the pattern of how to factor something that looks like this. So I'll kind of walk you through what that pattern is, and hopefully that'll help you make sense. Right? My whole thing about math is there's so many formulas to know. I try not to memorize them if I don't have to. If I can just see the patterns of how things work and how they relate to other things, And if I understand those patterns, then I just do that rather than memorizing a squared minus ab plus b squared and all that stuff. That gets too confusing for me, right? So x to the third plus 64. So when we factor one of these sum or difference of cubes, right, the pattern is the same whether it's a sum or a difference of cubes. It factors into two parentheses. The first one has two terms. The next one's going to have three terms. Right? In that first parentheses, I take the cube root of each of these, right? Which is what I found here, the x and the 4. All right, so it's going to be x plus 4, and the sign stays the same as what it was here. Right? So that plus, I keep that same sign in that first parentheses. Right? And if you looked at the other video that I did about these formulas, we said there was that thing called SOAP, right, which I'll put down here. Right? The S stands for same. The first sign that you put in here is the same as the original sign that you started with. All right? So I get x plus 4, and then to fill in my next parentheses, here's the pattern that we use. I take the first term here and I multiply it by itself. I do x times x, that gives me x squared. Then I do x times 4, that gives me a 4x, and then I do 4 times 4, that gives me a 16. Right? So when we're doing a sum or a difference of cubes, it's always that same pattern. It's the cube root of each of these. The cube root of x cubed is x, the cube root of 64 is 4, keep that sign the same, and then it's x times x, right? So this one multiplied by itself, these two multiplied together, and then the last one multiplied by itself to get that last one, right? And then as far as the signs are concerned, like we said, this one is the same. The O here stands for opposite. So whatever this one was, the next sign I put in is the opposite. So if this is a plus, that one's now a minus, it's the opposite. The A and the P stands for always plus, right? The one at the end here is always going to be a plus. Whether it's a sum or a difference of cubes, that last one's always a plus. Doesn't matter. All right, so that's how we factor a sum of cubes. Again, if you understand that pattern of how to put it together, it's just one less formula you have to memorize. And like I said, it's the same pattern for the sum or the difference of cubes, right? So just to kind of show you how that works, if this had been x cubed minus 64 instead of plus 64, well, it's the same thing. I still take the cube root of each of these, which is x and a 4. I still put the same sign as what I started with. So if that's a minus, this one's a minus. And then I still do x times x to get x squared. I do x times 4 to get 4x. I do 4 times 4 to get 16. Right? This one here is still the opposite. So if this is a minus, that's the opposite of plus. That last one is always positive or always plus. All right, so that's how that would look if it was a minus instead of a plus in the original. It's almost the same thing, except these two signs just get switched, whether that's a plus or a minus. All right, so that's how we can factor a sum or a difference of cubes. And like I said in that other video, those don't come up that often, but when they do come up, if you don't understand the pattern or if you don't know the formula for it, it's really hard to try to figure out on your own that this times this is going to give me x cubed minus 64. It's one of those ones that's kind of hard to piece together on your own. All right, as opposed to the next one, which is one of those special factoring formulas, but when I look at this, 4x squared minus 20x plus 25, I don't recognize that as being one of those special formulas, right? It's definitely not a difference of squares, because remember, the difference of squares only has 2 terms, right? So this one has 3 terms. It's not that. It's not a sum or a difference of cubes, because those also have just 2 terms. This one has 3 terms. So when I see something like this, I don't think about special factoring formulas. I think about, well, this is a trinomial with that 4 in front. Let me use the AC method. Right? And I did another video on the AC method, so if you haven't watched that one, you should check it out because I do a couple more examples there with things like this. So for the AC method, I multiply the A times the C, right? It's AX squared plus BX plus C. So I multiply 4 times 25. The first coefficient times that last constant term. All right, 4 times 25 is 100. So I'm going to look for 2 numbers that multiply to equal 100 and add up to equal that middle term, that negative 20. All right, so let's see what we got. 100 can be 1 times 100. It can be 2 times 50. 3 won't go into 100. It can be 4 times 25. It can be 5 times 20. 6 won't go into 100. 7 won't. 8 will not. 9 will not. It can be 10 times 10. And notice what I'm doing. I'm just going in order through the numbers, 1, 2, 3, 4, 5, 6, and just dividing each one into 100 to see what I get. And the ones that go in evenly, I add to the list. And I'm looking for ones that are going to add up to negative 20. Well, if I make this negative 10 times negative 10, those will still multiply to equal positive 100, but they're going to add up to equal a negative 20. And so negative 10 and negative 10 are the 2 numbers that I need here. All right, so remember, when you're doing these factorings of the trinomials, you do have to pay attention to the signs, whether you have positives and negatives, because it is going to affect what numbers you choose and what your final answer is going to be. All right, so once I figure out my numbers, remember, I use those numbers now to split apart that middle term. So I have a 4x squared minus 10x plus 25. All right, let me kind of put that off on the side there. All right, now I'm allowed to do that because negative 10x minus 10x does add up to a negative 20x. So these two lines here, what I have is equivalent. They just look different. And the reason I split those apart is because now I can use the grouping method to factor this. Because now I have 4 terms, so now I can do factoring by grouping. All right, so my first group, 4x squared minus 10x, those two have a common factor. Well, the 4 and the 10 share a factor of 2, and the x squared and the x share a factor of x. All right, so if I pull out a 2x, that'll leave me with a 2x minus 5. Right, and remember, you can always distribute to double check that. 2x times 2x is 4x squared. 2x times minus 5 is minus 10x. Right, and then with my minus 10x plus 25, well, the 10 and the 25 have a common factor of 5. Now I want this to be, or I want this second parentheses to be exactly the same as that first parentheses, which means I want to bring out the negative 5 here, which would make this a positive 2x and then a minus 5, and that makes these two parentheses match up. All right, if I just pulled out a 5 here, I would have a negative 2x and a plus 5, which doesn't match that first parentheses. All right, so remember, to do that factor by grouping method, you need both of those parentheses to be exactly the same, which in this case we had to pull out the negative with the 5 in order to make that happen. And now that we've got that, we're pretty much done. We just have one more step to get our factor. So that the parentheses that match, the 2x minus 5, that gives us one of our factors, and then the other factor is the stuff that we pulled out, the 2x and the minus 5. All right, and notice that those two factors are exactly the same. So 2x minus 5 times 2x minus 5, I can write that as 2x minus 5 squared, right? Because it's the same thing multiplied by itself, so that's 2x minus 5 to the second power. And so that is my factoring of 4x squared minus 20x plus 25. Right, so it turns out that that was a perfect square trinomial, right? Because it factors into a perfect square. Now, if you had recognized that from the beginning, that this was a squared minus 2ab plus b squared, you could have very quickly said, oh, well, that factors into a minus b squared. Right, so if you notice that and you remember the formula, it'll give you a shortcut to get to your answer. But like I said on that other video where I explained these formulas, if you don't recognize that, which, you know, if I'm just doing this problem, I don't recognize that. I just see a trinomial and I go to the AC method and I start to factor it. You know, it takes a little bit longer, but you still get to that correct answer. Right? So, again, the special factoring formulas, the perfect square ones are not necessary to know. The difference of squares is important. The sum and difference of cubes is fairly important. So definitely that difference of squares. Make sure you know that one because that one comes up all the time. All right, so that's our special factoring formulas.